My name is Tim Nakonsut, part of marketing for our STM32 microcontroller family here. So today I'll be talking about our entry into the sub-gigahertz world. So looking at our sub-gigahertz SoCs, both some in transceivers and essentially a little bit more dual-core features as well. So this is our complete offering that we have here. So you can see here kind of starting on the one on the left, our Spirit radio along with our STLP. Those are essentially transceivers. So if you had other customers that are looking to have already kind of used to STM32, whether it be an L4, L0, adding a sub-gigahertz radio of a co-processor or network co-processor could be a very, very simplistic solution to add connectivity in the sub-gigahertz realm. Then going on to the right, this is kind of our flagship little feature set here. It's our WL. It's a dual-core device, which I'll get into a little later, but it's basically a SoC with essentially a sub-gigahertz transceiver as well that supports multiple modulations, LoRa, FSK, GSK as well. Kind of go in the ecosystem. Essentially multiple stacks that can run on it that have been verified here as well. LoRaWAN, Sigfox, MBus as well. Any other customers looking to do anything type of proprietary, that's also supported as well. So very, very flexible, depending on what application and what region of the world that you're looking to use as well. So starting first, this is our WL. So essentially the WL was kind of birthed from a very, very low power L4 family. So a little bit of history, L4 was kind of a very, very market breakthrough, really combining a M4 class device with a very, very low power footprint. We added an M0 Plus to add a lot of security features in a dual core architecture along with the sub-gigahertz radio. This comes our WL. So as a top level, this slide kind of goes into the whole sub-gigahertz portfolio. So I mentioned before, a Spirit and S2LP, these are kind of standalone transceivers, so very flexible to a design system. So if you had maybe an L4, a U5, or something else, this adds a connectivity in a very, very transceiver type of application. Then our single core SoCs, so a little bit sneak peek, our WL3 is basically an M0 Plus with a sub-gigahertz radio. Then our top right are WL5 and WLE. So these are basically main SoCs, Cortex M-based class devices that are adding the sub-gigahertz radio as well. So a little eyesore here, but I guess the block diagram gives you a perspective of what the WL looks like. So I mentioned before, it's a dual-core device, an M4 plus an M0 plus, very low power. Definitely a lot of flexibility to run to boot up. You want to boot up the M0 plus or M4, depending on your secure boot architecture here as well. It's a 250K byte flash with 64K SRAM, but the key here is the multi-modulation radio. So it is LoRa capable, along with FSK, MSK, BPSK as well. It's 2 power amplifiers, so a little granularity. We have one that's able up to plus 15 dBm, and a higher power one that goes up to plus 22. Mentioned before, the WL is kind of a sub-derivative of our very low power L4 family. So some of the power numbers here are essentially very attractive for any type of very power conscious or battery applications. Standard peripheral set here, I2C, SPI, UART, a couple of timers that are very flexible. PWM, compare capture, and capture as well with multiple channels. And then we'll go into the advanced security features later. Wide voltage range, 1.7 to 3.6, and essentially extended temperature changes as well. So majority of our devices is -40 to +85, but for the WL, we see this landing a lot of industrial specs, so extending the extended temperature to +105 was a huge gain for us. Last but not least, 2 packages, QFN, and for applications a little bit more GPLs, we have a BGA73 as well. So the WL, kind of 2 points here, the safety and security. Starting on the left, a couple of safety configuration or peripherals that we have here. Dual watchdog, flash with DCC. We have an SRAM parity as well. We have something called the clock security system as well. So if an application, if you, for some reason or another, this edge node sitting out, wherever it may be, the crystal begins to fail, the clock security system is able to trigger that into a HSI clock. So essentially, it's a kind of another failure-safe mechanism. In terms of security, a lot of physical protections here. Tamper detection, read-write between the memory and MPU. Definitely have capability to run any type of crypto acceleration through AES. Last but not least, a couple of secure boot on the M0 Plus as well. So secure boot selection, key management, crypto library, along with secure provisioning and secure firmware install as well. This is basically available on the WL, which basically has the dual-core adaptation. So going on talking before, so essentially we have 2 power amplifiers within the device. We have a very low power LP power amplifier that goes up to scales up to plus 15 dBm. Then we have a full tilt in reaching up to plus 22. So depending on what your configuration, the WL can basically handle anything in between. Sub-gigahertz kind of give you a perspective of what the whole package lineup, including our transceivers. So I mentioned before, Spirit transceivers along with S2LP. S2LP considered the low power derivative of the Spirit, offered in QFN packages, both the 20 pin and 24. Then we have our WL3, aka our Spirit 3, our Cortex M0 Plus, and then all the way on the far top right is our WL. So very, very, very broad portfolio. You're going to look for just a transceiver on SoC from 64K flash M0 all the way up to a 250K flash M4 M0 split. So we wanted to make sure, obviously our silicon is what we're looking to have, but the ecosystem, we needed to make sure that was quite robust and tightly coupled for some of the stacks that I mentioned before, along with the low-level libraries. So starting on the left is our EVBs, or sample of EVB we have. So our nuclear boards, along with our expansion packs that would have the like the ST eval there for the S2LP. These are essentially the reference platforms that our customers like yourselves could use as a start-off or kickoff point for your designs. Development tools, we definitely solidify on two main partners for our compilers, Kyle and IAR. We definitely have our own CubeID, which is an Eclipse-based GCC compiler that uses OpenGDB. And then, like I mentioned before, the stacks is where it comes into play, depending on what your application. Supporting LoRaWAN, Sigfox. We definitely have other third parties like YSUN and MBus as well. Obviously, mentioned before, can be completely proprietary if your customers or your network deems fit. But definitely the stacks as well is something of a big push for us, because obviously that's, depending on application, that's where it's going to be lying hardest. So a lot of plug here, really kind of go into the more digital transformation that we have here. So anytime with the PR, looking for the community.com, st.com here, and some of the wiki sites for WL. So my last slide, any questions? Okay, thank you everybody. Enjoy the show.